The last class we started with the discussion on mesh analysis. We also did some numericals. Then we took a special case wherein we have a current source present and how we can apply mesh analysis with the current source. Now, with the current source present, you can have two cases. Either the current source is present towards the end of a mesh, or it can be present in between two meshes. So, if the current source is present at the periphery of any mesh, it is uh, there is no issue with it. You can easily solve it. But if a current source is present in between two meshes, like we'll be seeing in this circuit diagram. So we have two meshes here, and in between these two meshes, 1 and 2, there is a 6 ampere current source. So this current source is present in between two meshes. The issue with this is that the voltage drop across this uh, branch cannot be directly calculated. We have we have we because of the presence of a current source, but we know that since this branch in red, it is parallel to this branch as well as parallel to this branch. Fine. So these are actually two sets of branches to which it is parallel. So you can say the voltage across this point. So if I say VAB, VA, VAB, this voltage, since these all uh, fragments of the circuit are in parallel, so the voltage across all these fragments will be VAB. Fine. Or you can say the voltage across all these parallel elements will be same. Now, since we know that the current source, the voltage across this current source is same as that of any other parallel branch to it, or parallel branch that are uh, in parallel with this current source. So what we can do is we can ignore this voltage, we can ignore this current source for the moment and consider it as an open circuit. So since with an open circuit, the voltage is still present there, so we can still say that the voltage across this parallel or this open circuit is same as that of any other parallel branch to it. So this circuit will then look like. So whatever voltage is present here, same amount of voltage is actually also here. Same amount of voltage is actually also here. Fine. So these three voltages are, since these three parts of the circuit are in parallel, so the voltage across all these three parts will be same, and I have denoted that by VAB right here. But now since this element is open, that means current through this path is zero. Uh, there is Since it is an open circuit, no current is flowing in this path. So whatever resistance was also there, that resistance can also be ignored along with the current source. So you can have a number of resistances in series with this current source, but this whole circuit, fragment of these all number of branches that actually make a one segment will be still in parallel with another fragment of the circuit, because of which the voltage across all these points will be same across these parallel paths. So with I1 and I2 now, we do not have two meshes anymore. We have one super mesh in this case. So this whole circuit now becomes one giant mesh that is known as a super mesh. Now we can solve for the KVL equation of this larger mesh, that is the super mesh. So applying KVL to super mesh, in nodal analysis we used to apply KCL to the super node. Now we'll be applying here KVL to the super mesh. So 20 volt is equal to 6I1 plus 10I2 plus 4I2, which implies 20 is equal to 6I1 plus 14I2. So you can mark this as one equation, but we still need to find out another equation so as to solve for I1 and I2. Now we know for certain that in this branch, since this is a current source here, the current flowing in this branch is 6 amperes. It will not change irrespective of the resistances in series with this current source. So uh, from the current source, we can say that I1 minus I2 is equal to 6 amperes. So this forms your equation number 2. We have two equations. You can From this equation you'll get I1 is equal to 6 plus I2. Substituting this in equation number 1, you get 20 is equal to 6 into 6 plus I2 plus 14 I2, which is implies 20 is equal to 36 plus 6 I2 for 20 I2, which implies I2 is equal to 16 by 20 or minus 4 by 5 amperes. We are getting I2 equal to minus 4 by 5 amperes. And therefore I1 will be equal to 6 minus 4 by 5, that is 30 minus 4, 26 by 5 amperes. So these are your two values of I1 and I2 that you will obtain for this circuit. So this is how you can do a case of super mesh. Let's take another example. With this circuit, we can identify there are four meshes in this circuit, and let us denote the currents I1, I2, I3, I4 in these four meshes. But we have one current source and another current source. Both of these two current sources are present in between two meshes. So we can ignore both these two current sources and form one super mesh. So the super mesh will look something like this. So this now becomes open here. This also is open. Also note that I naught is this current. This is also open here. So this is 4 ohm resistance, 8 ohm resistance. So you have to only open the current source branch and all resistances in series with that current source. You have one independent current source here and one dependent current source here. So with that, both those two current sources, whether it's dependent or independent, they will be ignored and we'll get this circuit. Fine. So this is our circuit now. Now this whole forms one super mesh. So first applying KVL to the super mesh. Note that current I1 is flowing from here, current I3 is flowing from here, and from 8 ohm resistance the current is actually I3 minus I4, and from the 6 ohm resistance the current is I2. So by applying uh, KVL to the super mesh now, let's start from the 2 ohm resistance at the top. 2I1 plus 4I3 plus 8I3 minus I4. If current I2 is flowing in this direction, it will be positive. So 6I2 is equal to 0, which implies 2I1 plus 6I2 plus 12I3 minus 8I4 is equal to 0. This is one equation that we have. You can actually take two common from this. So it will I1 plus 3I2 plus 6I3 minus 4I4 is equal to 0. We can mark this as equation number 1. So this is our equation number 1. Now what we have to do is, now we know the two current sources. So from 5 ampere current source, from this branch, we can directly say that I2 is the current flowing in the direction of 5 ampere current source. So I2 minus I1 is equal to 5. Fine. So this is equation number 2. And from dependent current source, you have I2 minus I3 is equal to 3I naught, where I naught is what? I naught is actually equal to minus I4. You can see that here from this fourth mesh. So this becomes equal to I2 minus I3 is equal to 3 minus 3i4, or you can say I2 minus I3 plus 3i4 is equal to 0. This is equation number 3. Now we have one more mesh actually that we have not touched so far. That is this mesh number 4. So simply applying KVL to mesh 4, uh, in the direction of current, 2i4 plus 10 plus 8i4 minus I3 is equal to 0, which implies minus 8i3 plus 10i4 is equal to minus 10. So you have four equations, you have four variables I1, I2, I3, I4. Now we can solve for those four variables using these four equations and get the value of I1, I2, I3 and I4 in this case. So I1 is minus 7.5 amperes, I2 is minus 2.5 amperes, I3 is I1 is minus 7.5, I2 is minus 2.5, I3 is 3.93, and I4 is 2.143. These are the values you will be getting after you solve for these four equations. So let's do one more problem. We have an 8-volt source connected to a 2 ohm resistance. You have a current source here, you have a 1 ohm resistance here, you have a 4 ohm resistance here, you have a 2 ohm resistance here, 4 ohms, 2 ohms, 8 ohms. This voltage source is 8 volts, and let this be mesh number 1. So current I1 is flowing here. Let this be mesh number 2. So current I2 is flowing here. This is mesh 3. Current I3 is flowing in this branch. So by you again have a current source that is present. Now is this how to solve for this particular case? You have a problem here that this branch is not actually parallel to 8-volt source. Fine. So we have to see how we can how we'll be able to solve this particular case. So let us start by first ignoring the current source. The current source is 4 ampere. So we get 8 volts here. You have 2 ohms, 2 ohm, you have 4 ohm, you have 8 ohm here. Fine. So current actually flowing through here is I2. Current flowing from here, it is I1 minus I3. Current flowing from here is I2 minus I3. Current flowing from here is I3. And current flowing from here is actually I1. So by applying first KVL to the super mesh that we have formed, we get 8 is equal to 2 I1 minus I3 plus 4 I2 minus I3 plus 8 I2, fine, which implies 2 I1 4i2, 8i2 is 12i2, minus 2i3 minus 6i3 is equal to 8. This is equation number 1. Now from the 4 ampere current source, what we have is I1 minus I2 is the current flowing from that branch. So I1 is the current in the direction of 4 ampere current source. So I1 minus I2 will be equal to 4. This is equation number 2. From what else do we have here? From mesh number 3, KVL to mesh 3. We have 2i3. I'm starting with this particular mesh, particular element, 2i3 plus 4i3 minus I2 plus 2 I3 minus I1 is equal to 0, which implies minus 2I1 minus 4I2 plus 268I3 is equal to 0, or I1 plus 2I2 plus minus 4I3 is equal to 0. This is equation number 3. So equation number 1 can also be reduced. I1 plus 6I2 minus 3I3 is equal to 4 by taking 2 common here. So we have 3 equations, 3 variables. So we therefore have I1, I2, I3 equal to 1, 6, minus 3, 1, minus 1, 0, 1, 2, minus 4, inverse into 4, 4, 0. So if you solve for this particular matrix, you'll get the values of I1, I2, and I3. So, so on finding the solution of this equation, by solving for this matrix, you can try and solve this matrix. You'll get I equal to 4.63 I1, I2 will be equal to 0.63, and I3 will be equal to 1.473. So all values are in amperes. So with the super mesh, what you have to do is you have to ignore the current source, consider it as an open circuit, and by doing so, you form a larger mesh, apply the KVL equation to that larger mesh, and find out the solution to that larger mesh. So that will be all for today. We'll continue with our discussion in the next session.